Hello, so today I'll be talking about thermodynamics, Chapter 7, Thermodynamics. So we know that thermodynamics is a study of energy, heat, and the work of using systems and surroundings to study the transfer of heat. We know that systems are usually the environment that's controlled, in a sense, and the surrounding is like the outer universe and your surrounding areas. So when we're looking at thermodynamics, there's two laws of thermodynamics. The first one is that the energy of the universe is conserved, which is also known as the laws of conservation of energy. And the other one is that the energy expands, so that the universe tends to increase, so the universe is higher than zero, and universe is always expanding, which is the second law. Then moving on, we also talked about exothermic and endothermic reactions. So exothermic reactions usually occur from the breakdown, when there's a breakdown of energy and there's energy release. So it's a less amount of energy needed to break down a substance. And so it's a less amount of net energy that's needed. And then we know that the graph of an exothermic value is that the reactants are here, the products are here, and there's a decreasing value there as well. And that's a negative value because we have less amount of products and more reactants, so the value will be negative. Then we also talked, and exothermics are also spontaneous reactions. Yes, spontaneous is also the same as favorable reactions. And endothermic is the energies required. Endothermic is that the energy that's required to break down substances or molecules is higher than the energy that is released. So there's a net intake of energy, and they have a positive value as the reactants are here and the products are up here. Means there's a higher amount of products compared to the reactants, so it's a positive value. And endothermic reactions are non-spontaneous as well. Now moving on, we also have enthalpy, which is the change, it's a heat of body at a constant pressure. So we have enthalpy uses delta H sign, so it's delta H products minus delta H reactants. And moving on from there, we know that spontaneous reactions are the process that occurs by themselves without any outside forces, so they don't need anything else that allows them to be with it and for it to break down. And non-spontaneous means it needs something else. Although endothermics are non-spontaneous, there is some instances like when you're melting ice that allow it to be spontaneous. Now moving on, we also talked about entropy, which is the measurement of the degree of randomness or the degree of disorder. So kind of just like disorganization. And they have the delta S symbol. So it's delta S product minus delta S reactant. And when delta S is positive, it's a spontaneous reaction, and when delta S is negative, it's a non-spontaneous reaction. Moving on, we also have free energy, which is defined as the available energy for something to do work. And it considers the contribution of enthalpy and entropy. And free energy uses delta G, and it's delta H minus the temperature, delta S. So basically, entropy minus temperature and entropy together. Yes, and there's different cases between free energy, where one case could be where there's a delta H negative and a delta S positive. Another case is delta H is positive and delta S is negative. And the third case is when both delta H and delta S are both negative. And the last case is when delta H and S are positive. And usually when they're both the same sign, you have to rely on the temperature to be able to figure out if it's positive or negative. Now moving on, we have the determination of heat in a reaction, heat in a system. Heat is usually used by the symbol of Q, and that's the mass times the change in temperature times specific heat. And we know specific heat is the amount of heat needed to raise the temperature by 1 gram of substance by 1 degree Celsius. Right, and then when we're looking at the change in temperature aspect, it's usually if an equation gives us two temperatures, you'd have to subtract them, and then you use that subtracted value to multiply it to find the heat. Now, the last thing to touch on is kinetics, which is the study of the rate of speed in a chemical reactions. And they usually use the unit molarity per second because the speed of reaction is the molarity divided by the amount of seconds. And then a fusion collision is one that produces product molecules. And if sufficient energy is available, bonds break and atoms recombine in lower energy arrangement. And then lastly, the last thing we touched on was activation energy, which is the minimum amount of energy to initiate a chemical reaction. And there's exothermic and endothermic reactions. So for exothermic, there's smaller amount of energy needed to create a reaction, and for endothermic it's a larger amount because the reactions are here, the products are here, and it has to go up. Whereas for exothermic, the reactions are here and products are here, so it's kind of like a roller coaster where it's going down, so it requires less energy. And that is all for chapter 7.